In video lecture number 2, we're looking at the two prevalent models that discuss acids and bases. The first model is called the Arrhenius model, where acids are hydrogen-containing compounds that ionize to form hydrogen ions. Bases are compounds that ionize to yield hydroxide ions, OH minuses, in solution. So hydrochloric acid will increase the concentration of H plus ions by ionizing into H pluses and also Cl minus ions. If we have an acid like sulfuric acid, it will ionize into 2 hydrogen ions and a sulfate ion. And you're going to practice these equations for ionization on a worksheet. Sodium hydroxide will increase the concentration of hydroxide ions. And we see here sodium hydroxide, which is a solid, in water will break up into sodium ions and hydroxide ions. The second model is more conceptual. It's called the Bronsted-Lowry acids and base model, or the alternate acid-base theory. It starts off just like the Arrhenius model. An acid is a hydrogen ion, but we also call it now a proton. If you think of a hydrogen atom, it has a proton in the center and an electron that orbits around the outside. So the hydrogen ion loses the electron, and we're left with a proton. So an acid is a hydrogen ion or a proton donor. In other words, it gives away the hydrogen ion. A base, and this is where it's different, is a hydrogen ion or proton acceptor. And we'll see this when we do the problems. But this allows other species, which are basic but don't have hydroxide ions, to be considered bases. So all we're going to do now are these 5 problems on this next page, where we're going to identify the acid and base in the alternate base theory in the forward and reverse directions. So what we're going to do, and the best way to do it, is to say to yourself, what does this, number 1, turn into on the other side of the arrow? And we can see that this becomes the acetate ion. How does acetic acid turn into the acetate ion? Well, it loses, or it donates, an H plus ion. So it is considered an acid. The only place it can donate it to is the other thing on its side of the equation. So it donates it to the water, and the water turns into H3O plus. So it is considered a base because it accepted the H plus ion. But we can also do the reverse direction. In the reverse direction, H3O plus turns into H2O. Look for the thing that looks almost exactly like it. How does it turn into H3O plus? Well, it gets rid of, or it donates, a hydrogen ion. So it is an acid. It donates the H plus to the same thing, to the other thing on the same side of the arrow, which is the acetate ion. The acetate ion accepts the H plus ion and is considered a base. So very conceptual. Let's go through the rest of them. NH4 plus turns into NH3. How? it loses an H plus ion. It donates, so it is an acid. The hydroxide ion turns into water. How? By accepting the H plus ion, so it is a base. In the reverse direction, NH3 turns into NH4 plus. How? It accepts an H plus ion, so it is a base. Where did it accept it from? Well, it accepted it from the water, which turned into the hydroxide ion by losing the H plus ion. So it is an acid. So if it doesn't make sense, we can talk about it in class, but let's go ahead and do the last three. Carbonate turns into HCO3 minus. To do that, it accepts an H plus, so it is a base. Water turned into OH minus by losing an H plus ion, so it is an acid. In the reverse direction, HCO3 minus turns into CO3 2 minus by losing an H plus ion, so it is an acid. The H plus ion went to the OH minus, which caused it to turn into water. It accepted the OH plus, so it is a base. H3O plus turns into H2O, losing an H plus ion. It's an acid. Cl minus turns into HCl by accepting an H plus. It's a base. HCl in the reverse direction turns into Cl minus, so it loses or donates an H plus. It's an acid. Water accepts the H plus to turn into H3O plus. It is a base. And the last one, what does HPO4 2 minus turn into on the other side of the arrow? PO4 minus 3. How? By losing an H plus. So it is an acid. If it lost the H plus, the water had to gain the H plus. So it is a base. But in the reverse direction, PO4 3 minus turns into this by accepting. So it is a base. It accepted it from the water, which turned into H2O by losing, so it is an acid. Very conceptual, could be very difficult for you. We'll talk about it in class, but that's it for video lecture number 2.